So this video is on lessons 6 and 7. 6 should be a quick review. It is on the zero product law. Product meaning multiplication, zero meaning you're going to get zero when you multiply two things together. So when you are multiplying, let's say x times y, and you know the answer is 0, that means one of two things. Well, one of three things actually. Either x is 0, y is 0, or they're both 0. So if you are multiplying any two things together, one of them basically has to be 0. So down here, when you are asked to factor a trinomial, you get two binomials and you are breaking them up with multiplication. So there is an imaginary multiplication symbol between the two parentheses. Well, when we set it equal to 0, we're saying that one of these binomials has to be 0. You have to figure out what x could you plug in, what number could you plug in for x to get one of them to be 0. Some of them you can do in your head very easily. Look at this one. I know if x is 3, I'm going to get 0 here, and 0 times anything is 0. So 3 is a number that gives me 0 as a final answer. The other number could be -7. -7 will make the first term 0, and 0 times anything is 0. So while 3 makes one of them 0, it doesn't make the other one 0, but that doesn't matter because as long as one of them is 0, you're going to get 0. So to do this without having to do it in your head, this is where you did your t-chart, where you set each of them equal to 0 and solve for x. You have to know this process because some of them aren't as easy to do in your head as others. So this one, for example, to get x alone, you would subtract 7 over to the 0, so x is -7. And we already said that was one of our answers. This one you would add 3 over, so 0 plus 3 is 3. So these would be your two answers. That means that if you plugged in 3 or -7, you would get a final answer of 0 when you multiplied it out. Now this one is not as easy to do in your head. We want to know, well, this one's pretty easy, right? It's going to be 4. 4, if I set this equal to 0 and get x alone, I'm going to add 4 over. 0 plus 4 is 4. So if I plugged in 4, 4 minus 4 is 0. 0 times anything is 0. This one, you might be able to do in your head, but because of that 2 out in front, it's not as easy to do in your head. So you're going to add 5 to the other side. And then, so you get 2x equals 5, you have to then divide both sides by 2. So you get x equals 5/2, otherwise known as 2.5, but I would just leave it as a fraction. So those are your two x's that give you 0 in that particular trinomial, which was factored into two binomials. Okay, now this one, you do have to do t-charts for everywhere you see multiplication. In the other two examples, there were only 2 terms. But here we now have 3 spots where there's multiplication happening. So you got to set all 3 things equal to 0. Well, when you do this one, does 4 ever equal 0? No. So that one actually you don't really have to do, but if there were an x with the 4, then yes, you would have to make sure that you solve for x. This one, so 3x plus 2 equals 0. Oops, I forgot the 3x plus 2. Equals 0. So subtract the 2 over and then divide by 3. You get -2/3. And then 4x minus 3 equals 0. Add the 3 over, divide by 4. You get 3/4. So these two numbers are the two x's that would give you 0. Okay, so now the following questions are, you're going to have to use the zero product rule or law, but you have to first factor it yourself. So in order to start factoring, you need to actually get everything onto the same side first of the equal sign, and you need to get it equal to 0 before you can start your factoring. You want to make sure the x squared stays positive. So since it's positive on the left side, I'm going to move everything on the right side over. So I'm going to add the 2x over to the 3x, so that's 5x. And then I'm going to subtract the 10 over to the -14, so that's -24. Now I'm going to factor. I can use the 1am because there's a 1 in front. So it's x and x, and then the factors of 24 that can give you 5, it's going to be +8 and -3. Now, here's where my multiplication is happening. So that's where I'm going to draw my t-chart. I'm going to separate my two factors, and I'm going to set them both equal to 0. So you get x equals -8, and then you get x equals 3. So those are your two x's that work in this equation, and it would actually get you 0 if you substituted either of those in for x, or up here, you would get the left side equal to the right side. All right, letter B. So we have to bring everything on one side over to the other, and I want to keep the x squared positive, so I'm going to move the right side over to the left. So if I subtract the x squared over, that's 2x squared. If I subtract the 3x over, that's 9x. And if I add the 2 over, that's -5 equals 0. Don't forget to write the equals 0. Now I'm going to do split the middle. 2 times 5 is -5 is -10. So I'm going to split up 9 to be positive 10x minus 1x minus 5 equals 0. I'm going to group the first two and then the last two. I'm going to pull out a 2x to be left with x plus 5. This guy, I'm going to pull out a -1 to be left with x plus 5. So this factors to be x plus 5 times 2x minus 1 equals 0. And now I'm going to t-chart where the multiplication is happening to separate my two factors and figure out what x would be to make one of them 0. So x could be -5, or if I add 1 divided by 2, x could be 1/2. So there are your two x's that would solve this equation. Okay, so now we are going to do the exact same thing, but they asked it a little differently. They want to know the x-intercepts or the zeros. Well, if it's the x-intercept, you need to be thinking to yourself, oh, if it's the x-intercept, I know that y equals 0. So you're going to plug in 0 for y. Well, if you do that, it's exactly what we've just been doing. We're going to factor and then t-chart and use the zero product law to find what x's would work in that situation. So this is, I don't have to move anything over because everything's already on one side and I have 0 over here. So this is a perfect square. So it's 2x plus 1, 2x minus 1. If I t-chart where the multiplication is happening and set them both equal to 0, I get, subtract the 1, divide by 2, that's -1/2. Add the 1, divide by 2, that's +1/2. So at both of those x's, so here's like a visual of what's happening, at -0.5 and at 0.5, that is where your parabola, I don't know how far, whoops, that's a terrible parabola. I don't know how far down it would go, but a quick sketch of it is it would look like that, where it would cross at 1/2 and -1/2. Okay, so the next one, we're going to plug in 0 again for my y because I'm dealing with the x-intercept. I'm going to have to, first, I forgot to mention, you should always check for a GCF first. This guy does not have a GCF, so I'm going to have to do split the middle. So 3 times 10 is 30. I want to pick two numbers that multiply to 30 but give me 13. Well, that would be +15 and -2. So now if I group them, for the first two, if I pull out a 3x, I'm left with x plus 5. The second group, if I pull out a -2, I'm left with x plus 5. So one of my factors is x plus 5. The other factor would be 3x minus 2. I draw my t-chart where any multiplication is happening, and I set both of my factors equal to 0. So we get x equals -5 and x equals 2/3. Last one, plug in 0 for y. And first check for a GCF. There is one. You can factor out a 5x from both terms. In parentheses, you put what's left over when you divide it out. We get x minus 2. And now there is nothing left to factor in the parentheses, so you are done factoring. Here's where you're going to draw your t-chart where the multiplication is happening between your two terms. So your first term is 5x, your second term is x minus 2. Here's the multiplication. So you're going to draw your t-chart there, set them both equal to 0. And you get x alone. So this one, if you divide the 5 over, 0 divided by 5 is 0. Add the 2 over, x is 2. So what that means is your two x-intercepts are at 0 and 2. So it would look something like this type of, whoops, well, pretend like that went through too. Okay, so that is it for the zero product law. Moving on to lesson 7, which is the new lesson for this unit. Okay, so lesson 7 is the new lesson that you have not probably ever seen before, and it is on quadratic inequalities. So if you recall, an inequality means that there's going to be a less than or a greater than or a less than or equal to or greater than or equal to in it, which means there's going to be many solutions, right? Because there are many numbers that are less than a certain number or greater than a certain number. So your answer or answers for these types of questions are going to be intervals, or and you can write them using interval notation, which is with your inequality symbols, or you can write them using your bracket notation. Remember, the greater than and less than or equal to's are the square brackets, and without the equal to's, those are the curved brackets. Okay, so first we're going to start by just kind of trying to understand what exactly they're asking us to do by testing whether or not certain x values work for a certain inequality. So this says determine if each of the following is a solution, and you got to show your work to justify your yes or no answer. You can't just say yes or no. So to tell if a number works for that particular x, you're going to plug it in for x. So in here I'm going to have 4 squared minus 3 times 4 minus 10. And I'm going to see if that is greater than 0. 4 squared is 16. Negative 3 times 4 is 12 minus 10. We want to know, is that bigger than 0? 16 minus 12 is 4. Minus 10 is negative 6. Is negative 6 bigger than 0? No. So therefore, x equals 4 is not a solution. Now let's check 2 for this one. So that would be 2 squared plus 13 times 2 minus 7. I want to know if that's bigger than or equal to 0. So remember to follow PEMDAS. Do not do 2 times 2 first. You got to do 2 squared first. 2 squared is 4 times 2 is 8. 13 times 2 is 26 minus 7. Is that bigger than or equal to 0? 8 plus 26 is 34. Minus 7 is 27. It is indeed bigger than or equal to 0. So this one is a yes. And lastly, we got to plug in our negative 3. Be careful with negatives. That's why I like to use parentheses for when I'm plugging in a number for a variable. I just put parentheses around the number that's going in for x. I want to know if this is less than 0. So negative 3 squared is 9. A minus a negative really turns into a plus. And I have to strictly be less than 0. 9 plus 3 is 12. Minus 12 is 0. Is it true that 0 is less than 0? No. Okay, so moving on. Now we're actually going to break it down, and then I'm going to show you kind of a quick little shortcut. And then you're going to do some examples in class. So it says to do this, we are trying to find what x is, make this guy right here, x squared plus 2x minus 3, less than 0, so not equal to 0. Well, first I need to start off, and you'll always do this, this is step 1, find where this does equal 0. So you're always going to find where does it equal 0. To do that, you're factoring and then t-charting and finding which x's give you 0. So to factor this, it's a 1am. It's going to be x plus 3 times x minus 1 equals 0. If I t-chart, remember you do it where the multiplication is, I get x equals negative 3 and x equals 1. So those are the two x values that give me 0. Well, I want to be less than 0. So now I got to figure out, okay, is it going to be the numbers that are between these two, from negative 3 to positive 1, or is it going to be the numbers on the other side of these two? So any number bigger than 1 or less than negative 3. So to do that, you do not have to do this part every single time. This is just to show you. You would graph this, look at the table. So I have the numbers here for you. -5, his y-coordinate was 12, then you had 5. We know -3 is 0. -2 is -3, then -4, then it repeats. -3, 0, 5, and 12. So now let's look at our y values. We want to know when will we get numbers that are less than 0. Less than 0 are negatives. So that would be these guys right here, correct? Well, you got to be careful though. Do not tell me that it's from -2 to 0. I understand that we can't be equal to 0, but that doesn't mean -2 is the last number that works. It could be -2.5. It could be -2.9. So you need to tell me that it goes all the way up to -3 and all the way up to 1, but it doesn't include those. So that's why you got to be very careful if you're using your equal to's or your not equal to's. Your either lines or no lines underneath your inequalities. So explain why the zeros you found in part A are not part of it, because we can't be equal to 0. It strictly says we have to be less than 0. It must be less than 0. For this particular question, sometimes you can. Sometimes it says less than or equal to 0. So you got to really pay attention to what you're trying to find. So the solution set, they want us to represent it on a number line. That's not always the case, but so I will show you how to do it on a number line. You're going to start by definitely putting your zeros on there. So they were at -3 and 1. We cannot be equal to -3. So it's got to be an open circle, and we cannot be equal to 1 because that would be equal to 0. If I plug in -3 and 1, I'm going to get 0, but I want to know when am I less than 0. Well, I'm less than 0 from -2, or from -3, not including -3, up to 1, not including 1. So I'm going to shade, or some people did this, to represent that I want all of the numbers in between them, but not including them. To write it with interval notation or set builder notation, I'll do all of them. Interval notation, you could say it has to be all the x's that are bigger than -3 but less than 1. Or you could use this notation. We want to go from -3 to 1, and I'm doing curved because I can't include it. And then set builder would be all of the x's such that x is bigger than -3 and less than 1. So it's kind of taking the interval and putting it into set builder. So now let's do an example. This one says, basically figure out which x's could you plug in so that you're less than or equal to 0. So this time we can be equal to 0. So you always start by finding which x's make it 0, which means you're going to factor it and then t-chart it. So this factors to be x -9 and x plus 4 is equal to 0. We're going to t-chart. We end up getting x equals 9 and x equals -4. Now here's the trick I'm going to tell you. You can go to your table, graph it. We want to find all the ones that give us outputs that are negative or equal to 0. But here's a little trick. This is called sign pattern picture, okay? To do sign pattern picture, you're going to start by putting your two zeros on your number line, -4 and 9. Then you're going to plug in. We know that these are 0. We want to know if the numbers in between them are going to be positive or negative, and if the numbers on either side are going to be positive or negative. So pick easy numbers. Try to pick as easy as you can. So between -4 and 9, 0 is in between -4 and 9. So I'm going to plug in 0 for x. Well, that's 0 minus 0 minus 36. If I plug in when x is 0, I get y equals -36. So I'm going to put negatives in between -4 and 9, because all of the numbers, if I plug them in here, I'm going to get negatives. Now I have to plug in a number on the other side of 9. So that would be like 10, 11, 12. If I plug in 10, for example, so let's plug in x equals 10. I'm going to get, you could use your calculator again and just look at the table. 10 squared is 100. Minus 5 times 10 is 50. 100 minus 50 is 50. Minus another 36. That is 20 minus 6, 14. That's a positive. I really don't even care what number it is. It's just going to be a positive number. Now plug in a number on the other side of negative 4. So if you plug in negative 5, for example, if you plug in negative 5, I'll tell you right now, you're going to get a positive number. Now, look at your sign pattern picture. We want the x's that give us negative numbers because we want to be less than or equal to 0. Well, that's these guys. They give us negatives. So your answer is you want the x's that are from negative 4 to 9, and we can include negative 4 and 9 because we can be equal to it. And it said set builder, so actually I got to put my little squigglies, x such that, and there we go. All right, last one. Before you can start this one, you do have to get it equal to 0. So subtract the 10x over, add the 8 over. So this is going to be 2x squared. If I have negative 4x and I subtract 10x over, that's negative 14x. And then if I have negative 8 and I add 8 over, that's 0. That's gone. I want to know what x's make this side, the left side, bigger than or equal to 0. So again, you're going to start by factoring it. Well, you'll notice this is not a trinomial. So I'm first going to check for a GCF, and then if it's a perfect square, I'm going to use perfect square. Otherwise, you'll be done. So I can factor out a 2 and an x, and I'm left with x minus 7. Well, that's as far as you can go. You can't factor either of these two terms any further, so you're going to draw your t-chart between your two factors. So you get 2x equals 0 and x minus 7 equals 0. In this case, x equals 0, and the other case, x equals 7. So what that means is your two zeros are at 0 and 7. Now you're going to test numbers in between, numbers on either side, and see if they're positive or negative. Again, I don't care what they are. I just want to know if they're positive or negative. So a nice small number in between 0 and 7 is 1. Well, you can either plug in 1 into the original, or I would plug it into this one since it's a little easier. 1 squared is 1, times 2 is 2, minus 14 times 1 is 14. That's going to be a negative. So these are all negatives. If I plug in a number bigger than 7, so like 8. 8 squared is 64 times 2 minus 14 times 8. I'll tell you right now, it's going to be a positive. And lastly, you have to plug in a number less than 0. If you plug in negative 1 squared is 1 times 2 is 2. Negative 14 times negative 1 is a positive 14. So again, that's going to be a positive number. Now go back to the original question and see, wait, did I want positives or negatives? Well, look here. We want to know which x's are greater than or equal to 0. So I want to be positive. So this one's a little tricky. Basically, remember these are arrows, they go on forever. It's going to be all of your numbers below and including 0. So all of your negatives and 0. And then it's going to be all the numbers including 7 and above. So in set builder notation, because it's not in between two numbers, you have two separate, you're going like two separate directions. You're going to have two separate inequalities. You want all of the x's that are less than or equal to 0 union with all of the x's that are greater than or equal to 7. So you want to be less than or equal to 0 union with greater than or equal to 7. So there are two situations. If you plugged in anything in between 0 and 7, you're going to get a negative number, and that would make this untrue because we know a negative number is not bigger than or equal to 0. And that is it for lesson 7.